Hoodie Math coming at you live here. Not really live because I recorded this. I hope you guys are healthy and safe at home. We have example 4 ready for you today. We have a new hoodie. Shout out to Reebok. And let's go Blackhawks. Let's get our learning on. You know how we do. All right. Put in your earbuds. Let's initiate this. It's time and place for your educational greatness. All right, so where do we begin? Free body diagram. We have our mass. We have our F of K. We have a dampening force. We also have our mass with gravity. We know that some function f of t could be acting on this, and that we know that's 0 and down is positive. Those are all things we know at the beginning. Let's read through here. A 3 kilogram object is attached to a spring and will stretch the spring 392 millimeters by itself. A couple things have changed now. We're not talking about pounds, we're talking about kilograms. So M equals 3, just right off the bat. That's M. All right, so next thing we want to do is find, if I'm just going to go in order, M, C, K, let's try C next. Where would C come from? C is associated with the dampening force. We usually write F of D equation. We don't need to do that. We know C is 0 when there's no dampening force. In order next, we'd have K. So we want to find K. K again, M times G over the change in X. So what is our change in X? Well, this time it's 392 millimeters. Thousand millimeters in 1 meter. Let's change it to meters. All right, so we're good. We have our change in X. How we know how much the spring is going to stretch. Let's plug in our information. Are we going to use 32 this time? We're not talking about feet, so the gravity this time, remember, is 9.8. In the last video, I made a mistake. I said feet per second. So it's not meters per second, it's acceleration, meters per second squared. So 9.8 over the change in X. All right, so now we can write this. 3x double prime plus 0x prime plus 75x equals, well, this time we do have some function f of t. So f of t is 10 cosine, whoa, there's a W now. Uh-oh. All right. So what are we going to do next? Let's just continue for now, and I'll explain all of this in just a bit. The object is initially displaced 20 centimeters. Trying to trick us again, 20 centimeters, 100 centimeters in meters, so we got to move that decimal place over. Initial displacement. And then we have a velocity. And the object is initially displaced down, that's positive, remember. Equilibrium position at a given velocity 10 centimeters up, that's negative. 10 centimeters, we need to move that to meters. Again, so move that over. Meters per second. All right, we're good to go. And that's negative. So now we're good to go. So let's get back to talking about this W. The next thing I want to show you, and again, this is a doozy of a video. We have a lot of things to talk about and go over. So here's the next part. Let's look at this spring. As the spring goes up, you can see the phase space and the orbit of this point if it was just wrapping around maybe a pole. So as it goes down, we see it hits the bottom and goes up. It's kind of making a circle, right? And if we take that over time, we get this. So as the spring goes over time, right? So as that spring is moving, let me see if I can match it. Okay, it's in the middle, up, down, up, down. Over time, we create this sine wave, right? We roll that circle out, we create that sine wave. So there's a couple functions we're going to take note of. Y equals a sine wt equals a sine square root of k over m over t. Where did they get the k over m? And that's what we're going to discuss in this video, how we get that k over m. So a, again, amplitude. So I'm going to go to the top of the page here and discuss this a little bit further. So not a lot of things out there that I found that really put all this together, and I'm going to try to do that for you here. So Hooke's law, harmonic motion. Not oily boy, no. All right, F equals negative kx. That's Hooke's law. Spring constant is negatively proportional to the force. The other thing we can discuss is that formula we had. X of t. Right? Y, X of t, whatever. A sine W. Well, I'm going to call it A cosine. And I'm going to show you it really doesn't matter. It all depends on where you're starting. But I'm going to call it A cosine. Let's do capital A, but A cosine W of t. It's not really W, it's a Greek letter, but we're going to call it W. All right, continuing on. Let's take the derivative, because that would be the velocity, right? So let's call it x prime of t, which is the velocity. And what's the derivative of cosine? Well, it's negative sine. So negative, I'm going to make this capital. Negative a, and then chain rule, the w would come out, and then sine w t. All right, what would the second derivative be? The acceleration, which would be, all right, so we're going to have another w, so w squared. Sine's going to turn to cosine, so negative a w squared cosine wt. All right, so we have the acceleration. What other things do we know about math? Let's do on the side here. Force equals mass times acceleration. We know that from Newton's second law. How could I put all this together? Well, let's take this force, negative kx, acceleration would be this, negative a w squared cosine wt. You can see that. Let me throw that over here. All right, what about x? Oh, finally. So these cosine WTs can cancel. The A can cancel. Okay. Oh, and the negatives canceled, right? Getting a little closer. We solve for W. So let's move that over here. W would equal the square root of K over M. Okay, so that's where they get W from. W is the square root of K over M, and we're going to use that from now on. I'm not going to drive it again. All right, that was enough. But I wanted to explain. I didn't see a whole lot of people putting it together. They said, oh, by Hooke's law, by Newton's second law. But I didn't see a whole lot of them putting together. But if you just put those differential equations together, you can see the cosines cancel out, the A cancels out, and we get this simple W equals square root of K over M. I didn't want to take it for granted. I knew you guys wouldn't, so I wanted to make sure I explained it. Hopefully you can see the work I did there. But let's continue and move on. I don't want to make this video that long, and it's already going to get a little bit long. So now that I've explained that, we can move on with the problem. And it is a doozy. So let's go down here and let's define W now. Now that I've explained how to get this W, and I guess if you didn't want to know all that, you wouldn't have to if you want to just take it for granted, but I knew a couple of you wouldn't and would ask questions, so here we go. 75 over M. M is 3. So that's just 25, and then W is 5. So let's rewrite this. 3x double prime plus 75 x equals 10 cosine 5t. Alrighty. Can I divide by 3? I think so. I like that a little better. Okay, so now we have the real work. The real work begins. And I'm just going to draw a little line across here because here we go. Now we're back to where we started from before. If you remember how to set these up, I had to refresh my memory as well because it's complicated and intricate. So moving on from that position, we need our xc of t. A little reminder that I even had to refresh on. I knew it was there, but I had to find it on page 1 of the notes. And we've defined these as y before. I'm just defining it as x of t because that's how I've been doing 3.6. I'm just going to try to stay consistent with that. So xc of t, we got to figure that out. And so using this, we would know r squared plus 25 equals 0. That's going to be case number 3. Imaginary numbers. R equals plus minus 5i. That means a is 0 and b, I usually use capital B, is 5. All right, so xc of t, that's what we're defining now. So xc of t, well, it is case 3. E to the 0, this is going to go away. I'm not going to write that. Look up case 3 again. It's in the previous notes. But here it is. I guess I'll put a question mark since I really didn't define it there. What do we have? We have C1, cosine. (5t) plus C2 sine 5t. I'm going to lock that in. That's xc of t. So remember, as we're defining x of t, and we know xc of t, C1 cosine 5t plus C2 sine 5t plus y, oh, I did it. I knew I was going to do it. xp of t. So what would xp of t be? So let's make some guesses. Remember, we have to define it uniquely, that it's differentiated from x of t. So we already know that we have a 10/3 cosine 5t. So we look at a constant. We already have a constant taken up. We already have cosine 5t taken up. So we're going to have to add a linear portion to that. And remember, we can define it as something different. We can call it a cosine 5t plus b sine 5t. Right? That's what we would try to do, but we can't do that. We just talked about that. We have to add a variable in there. So we're going to add a t here and a t here. And now it's uniquely different. All right, so what do we do next? Oh, now that we have this defined, we have to take some derivatives, right? We have to work down to the third derivative. So I'm going to rewrite this here. I got this. Well, I can just kind of box that in. That's not really boxed in. So it's kind of squiggles. We're getting there. We're not finalizing that yet. All right, xp of t. At cosine 5t plus bt sine 5t. Let's take some derivatives. So the derivative of at cosine 5t. What do we get? Well, you take the derivative of t first. So a cosine 5t plus a negative, right? So 5 is going to come out of the product rule, minus 5at sine 5t. Now the derivative of bt. So again, I like to take the derivative of t first. Personal preference. Sine turns to positive cosine. So 5 comes out. All right, I think we're looking good so far. Let's move on to the second derivative. A cosine 5t, cosine turns to negative sine. 5 comes out. Negative 5at, take the derivative of t first. Negative 5a sine 5t. Sine turns to cosine. 5 comes out. 5 times 5 is 25. All right, I'm there so far. I've just taken that derivative. Now I'm on this one. B sine 5t. Sine turns to cosine. 5 comes out. Last one, again, another product rule. T first. Ooh, I'm running out of room. Negative 25 bt sine 5t. Okay, we're getting there. So let's go back to what we know. We know x double prime plus 25x equals 10/3 cosine 5t. I'm going to go ahead and start a new paper. I'm not going to use the space down here. So pause if you need to, because I'm about to put up a new sheet and plug all of this in to here. Okay, x double prime is, if you looked at x double prime, we can combine those 5a's to make negative 10a sine 5t, combine like terms. Same thing happens with the 5b cosine 5t. We can make that plus 10b cosine 5t. Then we have a minus 25at cosine 5t. Then we have a minus 25 bt sine 5t. Plus 25x. So plus 25 times x of p of t. At cosine 5t plus bt sine 5t. And that's equal to 10/3 cosine 5t. You hoodie math. Here we go. A couple things cancel out. That makes it a little bit easier. Getting closer to the end. So now we match up. Remember, there's no sine function, so this part equals 0. There is a cosine function, so 10b is equal to 10/3. So b is just 1/3. A is 0. So we needed to define yp of t. That was the goal. And again, it's not yp of t this time. It's xp of t. If you'd like to define as yp of t, go for it. Yp of t, xp of t. At cosine 5t. A is 0. 0t cosine 5t plus bt sine 5t. 1/3 t sine 5t. Gone. Xp of t, we worked so hard for a simple 1/3 t sine 5t, or t over 3. Are we done? No. Final step. Redefine it. C1 cosine 5t plus C2 sine 5t plus t thirds sine 5t, or 1/3 t. I'm going to go back to 1/3 t. All right, so you think we're done, right? Remember those? All right, let's find C1 and C2. It's actually not that bad. A lot of things cancel here. So we need our derivative. The derivative of C1 cosine 5t is 5C1 sine 5t with a negative in front. Cosine turns to negative sine. C2 sine 5t, 5C2 cosine 5t, t thirds sine 5t. All right, so 1/3. Let's keep that 1/3 in front. 1/3 sine 5t. Derivative of sine 5t would be 5/3. Sine turns cosine. I think I got all that right. Hopefully I didn't make too many mistakes, or any mistakes. Alrighty-o. Let's plug in. 0.2 equals, plugging in 0 for t, C1, this is going to be cosine of 0, which is 1, plus C2, sine of 0 is 0, plus 1/3, oh, thank goodness there's a t there, because that's 0. So we're just sitting at C1 equals 0.2. Plugging in next step. Plugging in the derivative. We'll use the derivative as red. Red is negative 0.1 equals negative 5 C1 sine 5t. Well, sine is at 0 is 0, plus 5 C2 cosine of 0 is 1, plus 1/3. Oh, thank goodness again. Sine is 0 at 0. And guess what I forgot that would have helped here? So I didn't make a mistake. There needs to be a t here. And that's going to help us because it's 0. And cosine would have been 1 here. So, made a mistake again, didn't I? Cosine here is 1. gone, gone, and gone. I have negative 0.1 equals 5c2. Again, I don't know why I wrote that as 0, but cosine of 0 is 1. Dividing by 5. Are we done now? Of course not. We have to write the last function. And here at Hoodie Math on a 25-minute video for one stinking problem, we write it in green. Green for gold. Green for go. All right, C1 is 0.2. 0.2 cosine 5t plus C2 minus 0.02 sine 5t plus our yp of t, our xp of t, 1/3 t sine 5t. And that's it. Any questions? I hope you have a few, because I think I still have questions. No, that's locked in. You guys take care. Have a good one. Tomorrow, 1 p.m. Arizona time, look for a live stream. I'll try to answer questions on the first 4 problems. Take care.